to organize, and we often have Scala India talks like once in once in a month or twice in a month, where we discuss some interesting Scala topics for the mutual learning. And at the same time, it's the Discord channel is where the community is. We have few things going around. We have Scala India Medium page where there are articles on tech blogs related to Scala. And if any one of you wish to contribute, message me. I would be more than happy to have you. And as well as if you wish to deliver some talk by yourself also, again, ping me up and we can schedule it someday as well. Apart from that, we have stuff going around. We have daily lead code where we solve one question every day, and more activities we will be having. And this every recording is available on the YouTube channel of Scala India, as well as this one. It would be recorded and uploaded, so you can always refer back. So and today's topic is being taken by Kannupriya Kalra. She has over more than 10 years of experience in functional programming as well as data engineering in Scala. Currently, she's working with Sky London in London. Previously, she had multiple roles across data engineering vertical as well as backend Scala vertical here in India. And she would be now taking over and will be telling more about herself, and we'll start the session. Yeah.
Thank you, Siddharth, for the warm welcome, and thank you for creating Scala India and for inviting me. Welcome, everyone, and I'm absolutely thrilled to have you all here today as we embark on an exciting journey into the world of GenAI. AI and Scala are very cool words, very cool technologies, and we know a lot about them already. So today's session is all about exploring how LLMs, which is another buzzword, can help us write structured, maintainable Scala code. Scala has so much potential in AI-driven development, and in this talk, we are going to uncover how it can be a game changer. I can't wait to dive deep into this topic and spark some great conversations, which we can then continue after my talk. I'll be very happy to connect with each one of you for any questions once we are done with the talk. And let's make the most of our time together here and explore the future of software development. And thanks again for making the time on Sunday evening. Thank you. Let's get started. Here's a bit about myself. Siddharth mentioned a lot already. Yeah, sorry about that. Yeah, so here's a bit about myself. And I have a decade of experience working with Scala and functional programming, focusing on backend development and big data applications. And I've also contributed to open source projects like Scala Dex, Scala CLI, and LLM4S. Mentored students in Google Summer of Code 2024, now 2025, leading it as an org admin. And I've also had the opportunity to speak at various global conferences. Start with the introduction again. So I was saying that it's time to set the stage now. And GenAI, particularly LLMs, are reshaping industries by making complex problem solving more accessible to anyone and everyone. And we all know how advancedly AI is going beyond, with LLMs at the heart of this revolution. And these models are driving automation in coding, decision making, natural language processing tasks. But can LLMs actually write production Scala code? That's what we are here to discuss. And then I gave some context on how, in the world of AI development, at this very moment, Python has been the dominant language. And it's all about Python here. And why is it? Why Python? And with that, it is because it's easy to use, it has powerful AI libraries, and it does boast without its shortcomings. which are lacking in type safety, runtime errors,
Let
and
me know. Let me know when we need to specify the
yeah,
slide.
yeah, I will.
Oh,
So Python is not shortcomings like lack of type safety, runtime errors, and scalability issues being some of the biting ones. And now we have Scala, enter Scala with its a very with it having a very strong type system, functional programming features. Scala can effectively address many of the Python's limitations. And in this session, we'll actually explore why Scala deserves a more prominent role in AI development and how we can, as developers, bridge the gap between the two. And we'll delve into how LLMs actually work and whether they can produce reliable, maintainable code that actually meets the industry standards. Siddharth,
yeah.
could you move on to the next slide, please?
Yeah. Now on GenAI and LLMs.
Yeah, yeah. Thank you. So, talking about GenAI and LLMs. So, now is the time to dive into how LLMs actually work. So, LLMs, in very simple terms, can be described as word guessers. I mean, give given a sentence, just try to guess what the next word could be. For example, if we say once upon a, we all know the next word is once upon a time. The princess and the Disney story goes on and on. So oddly, LLMs are so good at this storytelling, which is just the next word guessing. So here I'm trying to emphasize on how they actually work by correlating it with word guessing. So we can they are so good that we can then use them to write code one word at a time. So that's how internally it is working. And modern LLMs, which we all know now for sure, like OpenAI's GPT or Anthropic Claude, they are trained on massive amounts of data, and they use the deep learning techniques to generate human like responses. So, with which that makes the data makes them easy to produce more results. So,
Yeah.
so LLMs can be used in various ways. I'll talk about three main ways here. First one being zero shot prompting. Now what that is? It's the ability to perform tasks without the prior training on a specific example. It's like performing sort of a new task because we don't have a specific example for it. Then another way a LLM can be used is called tool calling. What that actually means is allowing LLMs to interact with external APIs and databases, which is something we all do a lot as backend developers. So, tool calling is the second way we can use LLMs, apart from zero shot prompting, the first one. And now the third way is self feedback, as the word suggests, self feedback, which can be understood as react looks, emphasizing on the word react separately, which means evaluating the tool output and then iterating to improve the results. So it's like improving itself based on the output, analyzing it, reusing it. So this whole concept of self-feedback improvisation, reusing the result, this is actually the core of agentic programming. That's what agentic programming is based on.
Yeah.
And we can enable LLMs to solve all kinds of problems like generating code, debugging errors, optimizing workflows. But how do they perform this in a strongly typed language like Scala? This is what we are going to explore further in the next slide. So that could you?
Yeah. Yeah. Changed. LLMs for writing. So.
Thank you. So, in this slide, um, we'll talk about three levels for writing software using LLM. So, we all know that AI powered development has come a long way, and LLMs can assist in writing software at different levels of complexity. I'll break down the different levels now. So, the first level, which is the most simple level, is if I ask an LLM to write me a function that add two numbers, it can do that easily. It generates a basic function, understanding syntax and logic, but without much context. Now, the
Hmm.
second level of complexity on which LLMs are working is a co-pilot level. So we all are now familiar with tools like GitHub Copilot. These work like they are like supercharged IDE autocomplete. It's like we are using in so we do have plugins like that in IntelliJ as well, who predict and suggest the next few lines based on the local context in that file, and they make coding more efficient.
Hmm.
It's like if we are doing lead code as well and we have our IntelliJ plugins added for it. Even if you're commenting there about the question that you're about to do, based on the local context in that file, it will auto complete the remaining code, write functions for you. So, this is like the second level of complexity where LLMs are making coding more efficient, reducing the boilerplate, catching patterns as we write, and they are the ones that when we add as plugins in IntelliJ, they suggest like code pop-ups like insert me based on what problem we are solving in the IDE.
Hmm.
Now moving on to the third level, which is called agents. Now this is where things get really interesting. Now
Hmm.
this is what we can, really use. So unlike Copilot, agents don't just predict the next line of code. What they do is they do one level up, which is they actively solve a problem. You give them high level instructions and they will analyze the entire code base, not just that file or that local context. They
Hmm.
will interact with the APIs. They will generate multiple functions and they will even debug their own output. So they don't just assist, they take ownership of the solution. So
Hmm.
if you see logs of an agent at work, so they are very smart. They whatever it is that they are doing, interacting with the APIs, databases, they are logging each of those instructions. And as a developer, if I'm seeing the logs of an agent at work, I can see how it actively records everything it did with great logging ability to track back if needed. So anything that needs, anything that's blowing up, we can just go back, track through the logs what the agent did wrong, and
Yeah.
help it improve. So, what's the key difference in these three approaches? So, Copilot works on a local level. They help within the context of the function or file you are working on. Agents, on the other hand, operate at a global level. So only difference was the context. Now, agents can understand and modify an entire code base, making them powerful tools for AI driven software development. We won't cover every single capability of LLMs today, but our focus will be on how they can be used for writing structured, maintainable software. Let's dive deeper
Yeah.
into the next concept. Yeah,
What is SWE benchmark?
yeah, thank you. So, SWE bench, let's learn about it. What is it? It's a very important concept in the world of AI. So, SWE bench is basically a way to benchmark the performance of these agents. So I just explained in the previous slide what agents are. There are multiple agents like these who are working. Because there are multiple agents, we have this SWE bench, a framework which we are using to evaluate which agent is better in what way. It's like comparing things on various levels. So it is basically benchmarking the performance of these agents, specifically for Python related tasks found in GitHub issues. So, what an agent does is it provides a standardized framework for evaluating how well these agents handle real world issues that a developer face. So if an agent is handling a ticket, maybe a ticket at work, and it has solved that ticket at 100%, you know, correct rate, so the agent is working well. And if the error rate of agent is somewhat 90% or so, the SW bench will, rank it lower. So it's based on how well the agent is doing problem solving in real time. So on what issues basically it's doing it in on Python related tasks, because I told you currently in the agentic programming world, Python is dominating. So Python related tasks, whichever tasks they are found in GitHub. Those tasks are being used to, evaluate how these agents are performing and, measure their level. So the set of issues used in SW Bench is focused on Python code problems, and that's why the evaluations are limited to this domain only. And we have agents, very, very famous agents, such as Aider, Open Hands, and Agentless. These are some of the top contenders that have been tested using SWE Bench. And though SWE Bench is useful, it's actually worth remembering that it only looks at a subset of possible issues, meaning that these agents might perform differently in other scenarios or a broader problem set. So that's somewhat a limitation of these agents. So we know that these agents don't generalize very well yet. They can solve issues, but they are far, far from perfect. Moving on to the next slide,
Yeah.
I will. So this is that leaderboard where you can see all of these are multiple agents being compared, and you can see that there's percentage resolved, there's org, there's date, there's logs. So some of them have ticks which shows that they have those things or they don't have those things, or how many, what's the percentage of resolved Python issues. And based on that we can see Open Hands is on the top. So as you can see on the leaderboard here, the performance of these agents is compared based on how many of the test issues they are able to solve, and they take a GitHub issue and the code base and attempt to generate the right software change. So I explained this already. And the biggest win so far are when the LLM get better. The tool still has a long way to go. So because LLMs are improving, the tools, have to improve too. Claude 3.
Can I ask a quick question? Sorry to interrupt. Can I ask a quick question? How do you know? So how do they measure if an issue was solved? By passing tests, or someone looks at it and says, yes, this is solved, or how does it work?
So so we have different agents, and we have Python related tasks, and a Python related task that has a problem statement, and a task has also a mention of what is the acceptable standard of solution for it. So whatever that is, some of the things that you mentioned. So if those things are done, maybe it's reviewed by a human sometimes, and sometimes for tasks which are not very complex, that can just be reviewed by unit tests or some other kind of tests to just see if those things are done, like creating a file, creating a directory, and then you can create a test that if something has been created there. That's a very simple task that I'm talking about. But for more complex tasks, they are evaluated by, of course, people. So Claude 3.7 was released, I think, 2 months back, and that is claiming further improvements. But this table only gets updated every week.
Hmm.
I'll now talk about the SWE bench and agent architecture. Siddharth, could
Yeah.
you please move to the next slide?
Yeah.
So I made this very, very simplified diagram to explain. So how do we make agents build software? So So a key innovation in AI powered development is SWE agent architecture. And think of this as an AI agent that is that writes code. And how does it actually work? So if you look at the diagram, we have a human and interaction
Hmm.
with the LLM call in the start. So we are seeing a human is interacting with an agent, and then you can see that the LLM call is interacting with the environment. Environment is the code execution environment where we can see that for an action we are getting some feedback. And if, like, going back to the question that I was asked, if the specification is met, then we stop. So we have to have some way mechanism in place to have those checks if those specifications are met for those tickets. And then this is going on and on. So what are those actions? Those actions are like writing code is an action, running tests is an action, running some shell commands are actions, and feedback is the result of those actions. So in a more specific way, the agent operates basically in a containerized workspace where it has access to tools and test environments, and it iterates just like a human, takes instructions, generates code, runs tests, observes results, and then repeats all of this. The agent's self-reflection mechanism, it ensures continuous improvements, like errors are fixed, tests are refined, and code quality is enhanced. And getting agents to generate Scala will help the agent do its work by giving more timely feedback. Example, type errors. This approach can be described in very simple words as fail fast, fail early, and speed up the development life cycle. Because we see that's the beauty of Scala, that even before we move ahead, we are able to solve a lot of errors just while we are doing the code. We are failing fast and we are writing better code. Moving on to the next slide.
Yeah, I'm at the next slide.
Thank you. So we are here about, so this is a call out to all the audience that we all know that Scala is a fantastic language for building robust and scalable software. That's exactly why we all are here today. And whether you are using Scala for backend development or for big data or for distributed system, I'm sure you must have experienced its power firsthand. But here's the challenge. While Scala excels in many areas, AI and ML tooling is overwhelmingly dominated by Python. And why is that? We have discussed it a bit in the previous slides. But more importantly, can we change that? Because we just saw how Scala fits better for this context. So it's dive into why Scala deserves. Let's just dive into why Scala deserves a place in AI development and how we can actually bridge the gap with modern LLM techniques and how projects like LLM4S are paving the way for a structured, type safe AI solution in Scala. And let's explore this together and see why Scala should be at the forefront of AI innovation. So, building AI tools in Scala is better, but getting LLMs to write Scala, which means it can build better code faster, or agents writing Scala code. So these are the two things that we are going to consider. Moving on to the next slide.
Yeah.
So Python is dominant in AI, but Scala offers unique advantages for AI driven development, and I'll break it down now. Building AI tools in Scala is better. Getting LLMs to write Scala, it can build better code but faster. So what are the things like why Scala? So the number one being type safety. LLMs often generate incorrect or inconsistent outputs, and Scala's strong type system helps enforce constraints, reducing runtime errors. Then the second reason being reliability and maintainability. Functional programming features like immutability and pattern matching, they help create robust, scalable applications. Then the third reason being a strong collections library. We all know the Scala collections library is very strong. I don't have to talk much about it. Anyone that has used Scala is very proud of its collections library, how simplified it is. Then expressive code. Scala's concise syntax, a very concise syntax, it allows for expressive AI logic without sacrificing the performance. So we are still writing expressive code, but that's readable and that's concise too at the same time. And the next reason being interoperability. Scala can integrate with existing AI tools while providing more structure and safety than Python. And fail fast option. Fail fast is giving good feedback. So this is what is the main reason. What a typed language can give you. It will always give you good, reliable feedback. And getting a good, reliable feedback is not something that we can get from Python. We can get it in Python using a hack, not directly by using Python. So Python language has its hack like adding Pydantic or MyPy to try and enforce things built into the language. Without using those, it's impossible to get good feedback. But with Scala, without using any of these hacks, because it's inherently a typed language, you can get good feedback. So we'll see how these features helps in real world AI driven applications. Moving on to the next slide.
Yeah.
Introducing LLM4S. So LLM4S is a new Scala-first AI development toolkit. And this project aims to bring structured, type-safe AI development to Scala. And here's everything that LLM4S will offer. Number one, structured AI workflows. So it will ensure AI-driven applications follow predictable, maintainable patterns. So predictability and maintainability is what's bringing structure. to the AI workflows, so which is very nice. Next, tool calling and API interactions. Seamless integration with external tools, APIs, and databases is the next thing. Then multi-step workflows. So LLM4S will support iterative development and feedback loops, which will be very similar to Python's LangChain. Fourth being Agentic workflow framework, which we discussed in the previous slides, what that is. Fifth, a Scala-native AI development, which means leveraging Scala's strength to improve reliability in AI workflows. So both in terms of tooling and in terms of code generation. So LLM4S is still evolving, but it promises to make AI development in Scala more accessible and efficient in multiple ways.
Hmm. Yeah.
Moving on to the next slide. To
Yes.
wrap up, let's recap everything that we have covered. Number one, LLMs are powerful, what they are, but we understood how current AI tooling is heavily Python centric. That's what we understood, what LLMs are, how powerful they are, and how it's all heavily Python centric at the moment. Then, next, we discussed how Scala provides better type safety, reliability, and maintainability for AI development, building AI and getting AI to build software both ways. Third point that we discussed was what a SWE agent architecture is, how it internally enables AI driven software engineering with feedback loops. And the last thing was my introduction to LLM4S, how it's being built, and how it's promising a Scala-first AI toolkit that brings structure to AI development. Now, what are the next steps for us? It's to get involved, whether you are a Scala developer, a AI enthusiast, or an open source contributor. We encourage you to explore LLM4S and help shape the future of AI development in Scala. Moving on. So, as we close, I encourage you to explore how Scala can enhance AI development. Think about what a type safe AI ecosystem looks like and how we can push the boundaries of AI in functional programming. And if you're interested in contributing, check out the LLM4S project on GitHub. You can explore open issues. We have lots of them. And you can join us in building a type safe AI powered Scala ecosystem. We greatly welcome collaborations from AI engineers, Scala developers, and open source enthusiasts alike. And if you enjoyed the talk, please consider starting the project on GitHub. And I'll talk about the maintainers in the next slide.
Yeah.
So before we wrap up, I would like to take a moment to introduce the incredible maintainers of LLM4S. Rory Graves is a Scala expert with over 30 years of experience and has made significant contributions to Scala compiler optimizations and AI driven research. A huge thank you to Rory for being an amazing co maintainer on this project and for his invaluable contributions to the creation of LLM4S and for the opportunity he gave me to work alongside him in maintaining it. And we would be delighted to connect on LinkedIn to discuss this project further. And we are looking forward to collaborating with you. And if you're interested in exploring LLM4S or discussing topics related to open source, Scala, and AI, we are also, we would love to have you join us at any of the upcoming London open source hack nights. And they are online as well. And you can find one of my LinkedIn posts related to this project. It's on my LinkedIn. And this image is from the Scala open source hack night in London, where we actually brainstormed this project and discussed it. And that's when it started. Moving on to the next slide.
Yeah.
So this is some food for thought for all of you to dive deeper. And here are some resources to explore the fascinating world of LLMs, intelligent development, and agentic programming. And these links provide insights into cutting edge AI advancements, evaluation frameworks, and open source projects that push the boundaries of Gen AI. I encourage you to check them out and continue your learning journey. And thanks again for being here. You were a fantastic audience, especially for being patient during some of the initial issues.
Yeah.
Feel free to reach out, ask questions, connect on LinkedIn, and let's continue the conversation and work together to shape the future of AI and Scala. Thank you.
Yeah. Great. It was great session. I think like we can open the stage for questions.
Mhm.
Anyone has any question, you can drop on chat, or you can open your mic and ask it away.
Um, yeah,
Yeah, so like we can hear you.
yeah. So actually, while doing code reviews, right, one major thing I see is especially in legacy code bases is uh, need to separate the pure functions and the side effectful things, right? I mean the so this pure functions more so that the unit testing and things are easier and it is easier to reason about code base and all that. Typical Scala, that is a style that Scala encourages, right? I played with IntelliJ AI, right? That AI assistant, and it helps a lot. I mean, but still, I see that at times it is not perfect, and I think some work needs to go into it, right? I mean, I was expecting a much better sophisticated thing, but yes, I think that is still work in progress. So
Exactly.
any thoughts on this? I mean, this is general thing. I happen to do it lot every day, so that would be a great help. So yeah.
Yeah, so you are right. Scala has various styles of, we have various styles of doing the code in Scala. So that was the first part that you mentioned. And I also agree with the part that when we are adding some AI based plugin, it is actually giving somewhat correct results. And I also happen to have had discussions related to this with some more people who tried creating Scala code with other tools in the market. And they were developers and they tried creating code for other languages as well. And they realized with the complexity of the language, how many errors are there when it comes to creating Scala code. So, yeah, I agree with all of these observations. And I have heard similar feedback when I had discussions around this with people in various other global conferences. And yes, this is a work in progress at IntelliJ's side for their plugin and for LLM Focus as well. The project started in January and we are hoping to finish it by September or October. So once the toolkit is ready, I would love to give a whole demo of it. I'm planning to do it in the upcoming Scala days in Lausanne, and then we can, see if it helps resolves these issues and how good of Scala code it creates. So yeah.
Thanks.
Yeah. Any more
Hi.
questions?
Yeah, and I have a question. I mean, it's a potentially vast question, but maybe just a high level. So, could you talk a bit more about LLM4S, like a bit about its architecture, maybe what kinds of frameworks you're using, and maybe also what are you? You said you're looking for contributors and so on. So, kind of what are the things you're currently working on? Where could you see people contributing to? Just a bit
Yeah.
around LLM4S.
Yeah. So this talk that I just gave was a teaser talk for LLM4S, to show it to the world that we are building this, and we have created a detailed uh, detailed readme on GitHub, and we have Discord with us, and you can see the open issues there. And I am about to come up with another talk, which will talk about everything, uh, you know, anatomy of LLM4S, basically everything that you're asking for. So currently it's under development, and we have like some of the features related to it built. But if you want to explore it and see how much it is built, we can have another call, and I can walk you through the GitHub issues, and I can show you some of the features. Like I can give you a demo. And given we have another Discord, and actively we have some open source contributors working on it, we would love to have you join, or at least have a one catch up call with me or Rory, and we can give you a heads up of the development done so far. But given I don't have the architecture or anatomy in place now, so I won't be able to share it in this call. But I would be happy to connect again on this.
That sounds great. That would be fantastic. Maybe some other people from this round are also interested in it. I'd be very curious. The teaser worked for sure. I got curious.
Yeah, I'm very glad.
Yeah, I had one question, Kannupriya. Thanks for the session. An excellent session. A teaser, I would say. So, this might be a bit technical, but let's say that as a developer, I have a certain taste, right? We are working in a specific environment where we have certain constraints, and we, as Atul was saying, right, we want to either separate out the pure code, and we want to make sure that side effects are only on the outer edges, and the core is always pure. But it's not happening. It's a mix. If we want to develop things quickly, we want to make sure that we are able to test things sometimes with side effects as well. So, as my personal flavor as a software engineer in my personal project, can I train the agent? Can I provide it these inputs that I like this style, and would it be able to provide outputs and write code in that manner? Is that possible?
So I'll come back to responding to your question, but first I'll go back to what Atul mentioned. So Atul mentioned, and you extended on it, how there are different styles of writing code. One being purely functional, and one being where we want to have those side effects, work with them. So this is a custom way of writing code, and like I explained in one of the architectures, we can train the model to work the way we want it to work. So based on your style, based on how you want things to be done. So let's say the agent has resolved 5 or 6 tickets, and someone asked me this question during the presentation, that how would we know if those tickets are being resolved. So let's say we have either used software developers help, or we are using some tests to understand how good the resolution of the ticket is, how well it is working. So based on that, how would that happen? Like, how would those tests check? How would that human check? So when Rory gave me one of the demos for this, he showed me couple of simple tasks, how agent was working on those tasks, and in the walkthrough that he gave me, he showed me a list of logs. So I could see the logs of first dividing the tasks into multiple steps, then doing some of the steps. Then maybe some of the steps it can't do, like giving permission or something like that. So a ticket for that will be uh, assigned to a developer, or some email, like basically requiring a human intervention. So that's a way, we are training the model, and now we have some tests, for example, with which we know, okay, these tasks are working fine, like this is the problem statement, this is the solution. Now with all of this data, we have sort of trained the model, and with all the feedback coming in, like you said, in your project you want to work with side effects too. So you can train the model however way you like, based on the tickets it's resolving, based on how you are training it. So yeah, that's the answer for it. I hope I explained it well.
Yep. Yeah, got it. So our test cases are going to train it, and what kind of acceptance criteria we provide it to, it's going to train it in that manner. Okay, sounds good. Thanks.
And you are gonna rate it down as well if it's not performing accordingly. So that's what we saw the SWE bench doing, where there were a list of agents. If you go onto that website, you can see there are lots of agents poorly performing as well. Not all the tasks are doing well, and that's why that's one of uh, the reasons we saw that the error rate was a lot in case of Python with the type safety issues, and that's how the idea popped in for creating this, because lots and lots of issues don't just come up if you are using Scala, given the type safety it offers, and given like inherently how the language is built. Yeah, happy to answer the next question if there is any.
I You have any more, Abhishek? You can ask.
Just a comment. I was saying that it might be risky to rate them down. They are getting quite advanced now, and they are
Yeah,
going to.
no, but see, they are getting quite advanced for the tasks they are able to solve. There are still tasks which are some of the basic tasks which are there, which they are not able to solve. So if a ticket has some task which they are not able to solve, only then we are going to rate it down. For anything it's working well, like the simple things or whatever things for which it does have a pattern or successful data with it, it's definitely going to match the acceptance standards and rated above.
Yeah, got it. Thanks.
I Yeah, Sita, you can ask.
Yeah, I'm also interested in contributing. So, but I don't have any knowledge about AI. But I have 20 years of experience software engineering and 10 years in Scala. So
Wow.
I might be useful or I might not be useful. I don't know, but I would like to contribute. I will start contributing, or I would like to start learning AI and exploring the AI LLM side.
I think so. A lot of people are interested to know the anatomy. So I think we can do another session someday here only. So
Yeah,
where you can take part two of this to explain and see and walk through the issues where people can potentially contribute. It can be an open discussion kind of a thing which we can do.
yeah. And because there's lots of people who are willing to contribute, I'm also going to share a link which has the
Yeah, sorry, I don't know about others, but I prefer to make my hands dirty always. That's how I start learning and then I expect things to be in particular order. So obviously computers won't listen to us. We need to listen to them, and then we need to do reverse engineering. That's how I learn most of the stuff. So I'm a very lazy in reading stuff. I want to make my hands dirty quickly, and then for that, of course, we need a nice introduction, and then slow, first in hello world. I mean, I call it as hello world thing. Then take it on from there. That would mean, if I mean, of course it also depends on others also.
Yeah.
It would be nice, it's a kind of a hackathon, or the and then like paid programming kind of stuff, or that would be nice for me. I don't know about others.
Yeah. If I was part of the audience, I think this is, you have put it very well. Yeah, that's how we all learn. Totally agree. Yeah, coming up with a new session shortly, definitely.
Yeah,
And I'm
I
very
think
happy that you guys are interested.
I'll drop an announcement, and over there people can react with a thumbs up. So I'll personally connect with everyone, find a suitable time so that everyone can join in. So yes, I will do this after the session. So okay, I think also I had one questions. Like you told us quite a lot about advantages of having Scala, like collection types and type safety and functional paradigm. Like, did you face something where actually Python stood out? Like somewhere you found it like, yeah, this is somewhere Scala could have been better, but right now it's not.
I mentioned this in the initial slides as well. Like, the very reason Python got picked up was how easy it was to use.
Mm.
So the initial learning curve of Python, being very less, was the first reason it got picked up. Then, it being a very old language, it does have a lot of libraries, and even if it doesn't have a lot of things, it, like, which Scala inherently has, it has a hack for bringing those things in it. So, having personally worked with Python and pandas, if you actually see, pandas library is very similar to Scala's library functions. So lots of the functions are very similar, but just the way it processes it, like, it's just added as a new library, as a hack to it. But with Scala, it thinks, how the language is built, it's just inherent. So yeah, with type safety. So everything in Scala, while you are writing Scala at the compilation stage itself, you will just start getting all the issues, and you have to, even if your code is purely functional, the overall test cases that you have to write are also very less. And then, good part about Scala is what Atul and one more person mentioned, that it does give you the freedom to do things your way too. You don't necessarily have to be doing things in a purely functional way, and you can do them with side effects too, but you can still get the benefits of the language,
Yep.
the JVM language. Yeah.
Yeah, right. Any more questions? If anyone has.
Yeah, on a slightly more generalized note, what do you think with Agentic AI coming in and stuff like that? What do you think is the future of software development in general?
I think the future of software development is very bright, especially for someone who has a lot of experience in it. Someone just said that they have 20 years of experience. I personally have 10 years of experience. So if anybody who has a lot of experience, they can use these tools to create and do better work. So yeah, that's, so everything is good. And if you just see, like, in hindsight, every time there was something new coming up, I remember when big data came in, and when Scala got in the pure functional language, it was one of the very first languages to bring pure functions. other languages started catching up and improving, and new versions of Java had it. So yeah, with AI also, you can just see it, just like, we were happy when calculators were there, we were happy when we got copilot, and then we saw how we can use agents to even do better. And now if you'll just break down agents, and if you'll go back to the past industry trend, I think 5 years back automation was very high. And what automation was really doing was, manually, the developers were figuring out patterns and creating a workflow out of it. So everything that AI is doing is sort of the similar thing, just finding patterns and just a way to do things better with better tools in hands. So my personal perspective also, because I'm working on building this library, is that we will have better tools to do our work better, create better work, do things faster. So yeah, we have more things to learn, and it's very interesting. So even if you'll start with some open issue with LLM4S, you will see that how interesting it is. And overall you will see it's the same work that you are doing, just using different libraries. It's nothing like very new. It's the backend development tasks only. You all know what logging is, you all know what testing is, what feature building is, just a new way of building it. So yeah.
Thank you.
Yeah, very fair. So, any more questions?
Just a hint. I just googled LLM4S, and the first thing that came up is not your library; it's another one. It's
Yeah, I
Scala
also,
3 binding. You saw that? You have to You have to ask them to bring it down. It doesn't seem very active. Yours should come up first.
Yeah, I was told by Siddharth about this. I just sent you the open issues link and the link of my library. And I'm very happy to see we have 16 stars. If all of those people who said they liked it and they are looking forward to getting it built, it would really mean a lot to me if you'll star the project. And yeah, I've just posted the link here, and I'm gonna explore it, what the other one is. And having worked on Scala decks, which shows, it's a library page of all Scala related things, I also saw something related to LLM4S, and maybe it's another project with a different thing. So I have to explore and see.
I
But I
think
think
now it has become very common, kind of a thing that something for S is now something very common, a nomenclature that has become.
maybe, but I've just posted the right link for my project
Yeah,
with its.
I'll put that in announcements also.
Yeah, I don't think, just put the right link, but yeah, not this.
Yeah, yeah, right. Yeah.
One more thing, you mentioned your upcoming London Scala workshop. So I've seen announcements of it around here and there, but is it like open like globally, or is it for London specifically?
Yeah, so we have two open groups in London. One being Scala Bridge and one being London Open Source Hack Night. So in both of these, we work on open source projects which are open globally, and they both have online events, like one of these events where people connect and they divide into groups and they work on separate projects, groups of 4 or more based on the projects. London Open Source Hack Night has a list of projects like Scala CLI, Scala Dex, FS2, like lots of open source Scala projects where the maintainers and some of the people are working on. And if you want to, like, including LLM4S is also there. So if you want to work on it, you can join one of those online sessions and connect with more people. But for LLM4S specifically, we have our own Discord. I have shared the link as well. You can go introduce yourself there, and yeah, we are very happy to connect and help you with it. You can try up some open issue. You can go through what's going on in there